Okay, so we're going to start off solving some of these trig expressions. We're going to start off solving cosine of x equals square root of 3 over 2 for all solutions. And I also wrote down here an inverse just so we can see the difference between the two. Because remember, the inverse was basically saying what angle cos of theta gives me square root of 3 over 2. So these look like they should be the same thing. And they do have the same idea behind them. They're just trying to see what you can sub into cosine to give you square root of 3 over 2. But inverse, we were kind of blocked on the range. Range of the inverse only for cosine went from 0 to pi. So the only inverse of cosine that gave you square root of 3 over 2, hopefully you have your chart with you, would be the third one down. So pi over 6. So I would say the cosine inverse of square root of 3 over 2 equals pi over 6. Now, when I'm working with solving them, I'm not going to have that same restriction of the range. I'm going to say I want to solve this, and I want to solve this for, I don't know why I put down, well, we'll do all solutions. So I want to solve it for all solutions. So I know one solution. I'm going to go ahead and draw a unit circle up here. So I know that pi over 6 will give me, cosine of that will give me square root of 3 over 2. I could find another solution because I know cosine is positive also here because it's x, so it's positive over here. So this pi over 6 down here would give me another solution. So if I go all the way around, that would be almost back to 2 pi would be 12 pi over 6. That'd be 11 pi over 6. Oh, this was supposed to say pi over 6. Okay. And other stuff could give me it. And what other stuff? I mean, I could come back up here. If I came back up here, because don't forget this is a circle. If I came back up there, I would get another answer. This would be 12 pi over 6 plus pi over 6, because this is 2 pi. That would give me 13 pi over 6. In fact, if I went down around the circle again another time to get 4 pi, so 4 pi would be 24 pi over 6. Then another pi over 6, 25 pi over 6 would give me another solution that works. And you see, I can just keep going around a circle as many times as I want. So when we have all solutions, we actually just look for the two that are in our first section of the unit circle. So meaning one period, so in between 0 and 2 pi. And then we say, okay, pi over 6, and if I went around a circle, I would get back there. Circle's 2 pi. If I went around a circle again, I'd get back there, so we'd add on another 2 pi. If I went around a circle again, I'd get down there, so we'd add on another 2 pi. In this case, if you add something over and over, it's multiplying. 2 plus 2 plus 2 plus 2 is 2 times something. So I'm going to say 2 pi times k. K just means I'm not sure how many times it's going around. I'm going around forever. Also, k can be negative, so it counts into the going backwards around a circle. Okay, so I'm going to do the same thing with 11 pi over 6 plus 2 pi, because it's going to be true every time I go around that circle. Okay. Okay, so the difference between inverses and solving, and how to write it out when you're solving for all solutions.